Hello everyone. Today we are going to give you an overview of Autodesk Advance Steel, which is Autodesk's product for steel structures that produces detail and fabrication drawings that we would otherwise create manually. It is fully integrated with AutoCAD as one product offering. It is part of the AEC collection, but it's also available on its own. And it really fits nicely into the mix here because many detailers are doing this work manually or with third-party tools. In addition, it complements Plant 3D and Revit, which by themselves weren't built for the level of detail that structural steel needs, but we do still do some steel in those products. Here's what we're going to do today. We have some structure already started and we are going to finish it. You'll see how to create a few things like columns and beams, footings, some stairs. We'll do some railing, a cage ladder, and a few connections. Then I'll show you how the software generates detail and fabrication drawings. After we look at the drawing features, I'll show you how to bring structure in from Plant 3D as well as Revit and share some of the best practices with you. Let's get started. So here is our structure in Advanced Steel. As you can see, this is integrated with AutoCAD. So those of you that are AutoCAD users, you should feel right at home. Now, these objects that you're seeing on the screen here are intelligent Advanced Steel objects. So there is a database that's under the hood that manages all the information. And we also have some additional tools that ride on top of AutoCAD when you're working with Advanced Steel. I've got a couple of them floating right here. There is a set of advanced tools. There's a connection vault. We've got some other tools for producing the drawings, which we'll look at in a little bit. Now, I want to just show you what we're dealing with under the advanced tools. Now, there's an awful lot of features in here at your disposal. There are some that are still native AutoCAD commands, like the ones we're looking at here. These are the tools for working with the UCS, which is native AutoCAD. Advanced Steel has made a place for them in its tool set, just so you only have one place to go to for all of the common tools. Now, that way you're not going to one side of the interface for this command, another side of the interface for another. It made a nice centralized location for the key features. And a lot of them are still AutoCAD features. We also have some advanced tools for working with the more intelligent objects. We'll take a look at some of these as we go. We can also do custom connections for those of you that aren't satisfied with the out-of-box connections that you'll see. We do have the ability to create custom connections when we need them. We've also got some selection and filtering tools to distinguish between AutoCAD objects and Advanced Steel objects. And we also have some additional features for things like miters, coping, shortening and lengthening some objects like beams and columns, as well as tools for contouring or cutting holes in objects, creating notches and things like that. So we'll touch on each of those as we go here. And that's the advanced tool palette. There's also a connection vault, which comes with Advanced Steel. And in the connection vault is pretty much any type of structural connection you can imagine. Personally, I have not been at a loss for a connection. If I was looking for a particular type, it's been in here. So I haven't had to create anything from scratch or color outside the lines, if you will. There seems to be plenty in the connection vault already for any situation. So we'll touch on those. Over here on the right is the Project Explorer. And this is going to come in handy when we have a multi-level structure like we do here, and allowing us to constrain certain objects to the appropriate levels. That way, if things change, then we've got some control over those objects versus how we would do it with native AutoCAD, where we would have to use all the different selection methods, make sure we pick all our objects, do some stretching. Are we working in the X, the Y, or the Z, and things like that. The Project Explorer takes care of all of that and really cuts down on our picks and clicks. With the Project Explorer, we will also have the ability to determine the lengths of things like our columns and provide constraints to the base and the top and tie those to our levels as well. And with this tool, it really starts to have a feel kind of like some of the features in Revit. So if some of you are also using Revit, you will see some similarities here. The difference is what the dialogues look like, you know, in the AutoCAD interface versus the Revit interface, but the underlying purpose is the same. All right, now to show you what we can do with the levels. I've got this already set up, and what I'm going to do here for a moment is pretend that what I want to do is lift up the upper level here a few feet and watch what happens to the objects on that level. That's level 2. So over here in the Project Explorer, I'm just going to go into Properties, and I'm going to change the elevation and raise it a few feet. Notice, though, that nothing really happens, but I do see that there is this one little red indicator that has appeared all of a sudden, and that happens to be the indicator for that level. Level 2 is now sitting at 30 feet, level 1 is at 12 feet, etc. But when I made that change, the only thing that moved was that indicator. So I raised the level, but none of the objects that are supposed to be on that level changed. So what I want to do is I want to attach the right objects to that level so I can get control over those, and I don't have to use regular AutoCAD commands like stretch and have to repeat that because I missed something. So to make things easier on myself, I'm going to change to my front view just so I can look straight at it. There's the indicator for that level, and I'm going to attach the objects that are on that level. And here's how I'm going to do that. I'm going to come over to the Project Explorer and switch to the Work Planes tab. And there's my 3 levels, and I'm going to right-click on level 2 and choose Attach Elements. And this is a 2-part command. The first part, we select the objects that we want to bind to the work plane. I'm going to use a crossing window to do that and make sure I surround everything that's up on the level. And I also want to select the columns that are approaching that level. Those are the objects I'm going to attach. I'll press Enter. And then I'm going to select Geometry Points. And that's an Advanced Steel feature. The geometry points are these little red balls that you'll see scattered around your model. There's one at the top of each column. You might see one on the grading. There's also some red balls down on the base of each column. So now we're attaching the geometry points to the level. I don't want to attach them all. I only want to attach the top ones. So I'm going to just repeat my selection. I'm going to do a crossing window or a regular window, as long as you surround all the red balls that you want to attach to that level, and then press Enter, and you'll see the structure on top there move when I do that. So now level 2 is in control of everything that's up here. And that makes it a whole lot easier when I need to move or adjust anything. All I have to do is go change that elevation back here in the properties for level 2. I'm going to set this back to 24 feet, which is where it was to begin with. And you'll see everything move down, just like so. That is much easier than having to repeatedly select with the stretch command and run the risk of leaving something behind, like one of these connection plates and so forth. So that is one of the powerful things that you can do if you're using the Project Explorer and you're creating levels for your model. All right. So now let's move on and finish our structure. We're going to create a couple of columns. couple footings in this area right here to add an extension to this structure. Since I'm going to do the columns next, I'm going to go back to work planes and I'm going to set my constraints. I want my bottom constraint to be level 0. So I'll select the bottom bar right here and then choose level 0. For the top constraint or top work plane, level 1. So now any column that I place, it is going to span from level 0 to level 1, no matter what. So I'll start the column command. I'm also going to invoke a new snap that comes with Advanced Steel. It is the grid intersection point snap. And as you can see, I have no other running snaps turned on right now. So my only option is the grid intersection. The grid is intelligent. It's an Advanced Steel grid. It's not just lines, bubbles, and text. So now I can pick, and each time I do, a column gets placed. So I can do this as many times as I need to across my grid. I'll just do those two. When I'm done, press enter, and that will bring up the Advanced Steel interface. And now I can work on the properties for these two columns. So I can set the type of shape I'm going to use, the standard that it comes from, and the size. Over here on the positioning tab, I'll set the position. Since it's a column, I like to make the positioning dead center. If I need it to be rotated, I'll set the angle. It goes in 45-degree increments around the compass here. Notice that whenever you do make a change in the properties in Advanced Steel, you can see those changes in real time on the model because the dialog stays open while you're making, and while the model is receiving these changes. So we'll leave that the way it is. We'll make sure that the columns are centered, and we'll close out. So that's how you can place a column. Next, we'll add some footings underneath. Footings are a little bit different than columns. Again, I'll use the grid intersection snap. And the difference here is each time you click to place a footing, that footing will get placed. So it won't be, that's where it's different than columns. Go ahead and set the size of the column, the footing, and then we'll finish it. So it's a one-to-one command when you're doing the footings. I could use AutoCAD copy right now to place the other one. I could use advanced copy, which is Advanced Steel's copy command, or I could just hit enter and run the command again and pick my next point and place the footing. The difference here is Advanced Steel didn't remember the settings that I just used on the first footing, but that's okay. We can do this so quickly. It really is no difference in how you place those. Now, if I was doing a very large number of footings, then I would rely on advanced copy to do that. And I'll show you advanced copy here in just a minute. So just want to get a couple columns and a couple footings placed. And then we'll add a few beams. Now, since the beam's running in horizontal fashion, I'm going to go back to the Structures tab of the Project Explorer and activate level 1. So right-click on level 1 and activate it. And that does two things. First, it reorients the model to a top view, like so, and it will hone in on grid A1. So what we'll do is we'll just zoom out so we can see the whole thing. Now, if I wanted to, I could orbit back to 3D and continue working. But I know that there are a lot of detailers out there. They prefer a 2D look and feel when they're working, and that's what activating the level will do for you. That's the first thing. The second thing that activating the level does is it sets that constraint. So now, wherever I place my beams, they are going to be constrained and located on level 1. So they'll be at the appropriate elevation. I'm going to still use the same grid intersection snaps to do it, though. All right, so let's start the beam command. And we're going to place a few beams in this location here, snapping on the grid that's down on the floor. Press enter when we're done. We'll use the same structural shape here for the beams. We'll just change the positioning to be top center. And then we'll orbit back to 3D, and you'll see the results. So they all line up with the existing ones. But notice that those beams are up at level 1 versus down on the floor, which is where I snapped. So if you're a 2D user, you prefer looking at things from a plan view, then you can do that. Or if you like to work in 3D, then it's okay to orbit back and watch things develop in 3D fashion. To illustrate that, I'll delete these 3 beams and just replace them real quick. Just so you can see that even though I'm snapping down on the floor, the beams are being placed in the correct location regardless. All right, so there's our beams. They've got their constraints in place. But I want you to notice here that when I activated the level and we turn back to a 3D view, some of the model is not visible. Level 2 is not visible. We also can't see the footings down below. And the reason for that is due to the visibility controls that you have with each of your levels. Right now, if you notice, level 0 and level 2 are off and level 1 is on. So we can only see what is constrained to level 1. If I want to see the entire model again, I'll just deactivate that visibility by turning off that light bulb, and now we can see the entire model again. So as you're working and your model gets more content in it, and you just want to work down on your ground level, you can activate that visibility, and now you'd only be looking at what is at level 0. Or level 2, you'll see what is at level 2 and a little bit below. So you will get a little bit extra in each case, but it is a great way to focus in on your model while you're working. And it is, I think, a better alternative than turning off this layer, turning on that layer, and getting back in some old habits where we're managing our visibility with just the layer tools in AutoCAD. So you can still do that, but this is an added benefit, and you can do it very quickly. All right, so there we got our beams that we're going to use here. And next we'll add a couple of connections. We've got some already in the model in various locations. And what we want to do now is add connections to our new components here. We'll go into the connection vault, and we'll add a clip angle and do that between column and beam. And then we'll just close that, and I'm going to replace one more over on the other side. There we go. And let's take a look at that connection. So all you would select when you place a connection are the elements involved, in this case the column and the beam. What you get is the clip angle, the bolts. If there's welds that are part of that connection, you'll get those as well. Got it on both sides. So a lot of objects get created with very little effort. Now, in the properties for a clip angle, you have control over everything. The size of the angle, what it's made out of, what the welds are doing, how it's going to be coped. If the beam has to be coped, as you can see here, coping is included in this connection, so you don't have to do that in a separate step. You also have control over what your bolts are doing, how many you have in each direction, your spacing, and so forth. We also have access to the library, which has some out-of-box connections already placed, but we also have the opportunity to save what we do with those settings so we can reuse ours in addition to the out-of-box. And you'll see me rely on the library quite a bit in some of the upcoming tasks. For now, we'll just go with the default. All right. I also want to place a couple clip angles back against the taller columns since there are beams on the other side. This time I'll use a double side clip angle. That way I can pick both beams and get all of the clip angles included in one connection. So instead of getting 2 clip angles, you're actually getting 4. There you go. Now for the next set of clip angles, I'm going to do those a little differently across this beam here on the end, because I'd like to show you the advanced copy command. So what I'm going to do here is I'm going to delete that beam right there. It didn't have any connections on it yet, but the one back here does. And so I'm going to use advanced copy to achieve that. But I'm only going to pick the beam. Now I could use the regular copy command, but then I'd have to go and select everything myself. I'd have to select the bolts, the welds, and the angles, all the pieces and parts. I don't want to have to do that. And that is where advanced copy comes in. So you can find that in the advanced tool palette. And the advanced copy command includes the other modify operations you would normally do with AutoCAD: array, move, rotate, mirror, and so forth. Copy is the default. And there's also an include additional connections option. So if I'm not using that, only the beam is selected. When I check that box, now I've got 5 objects selected, which means everything that's connected to the beam is included in the selection. All I have to do now is establish the number of copies that I want and the direction or the distances in each direction. I'm going to pretend I don't know the spacing of my grid, so I will select my direction and distance just by picking in the same grid intersection points. So now I know I'm going to be making this copy 20 feet in the X direction. Next, I'll use the preview option so I can see what I'm about to get. I'll select the corresponding entities here. Now, when you're using advanced copy, you'll get a small dialog that looks like this. It's the preview panel, and that gives us a chance to verify what we are copying, make sure we got it the way we want. I overdid it, so I'm going to choose modify. That'll bring you back into the advanced copy dialog, change the number of copies. We'll preview again for good measure. When it looks good, then we'll click OK. And now we have a beam and all of the connections along with it. And that is a tool that I find myself using quite a bit. All right. I'm going to do a couple more connections here for some base plates for the columns. And we've got a lot of footings here and a lot of columns, but we don't want to have to do any additional copying or anything like that. Let's see if there's a better way to do that. So first we'll go to the connection vault and we'll add a base plate to the base of our first column. Again, all of our properties are available to us, so we can configure that. We can also go to our library. Right now, just accept the default. But instead of using advanced copy or just running the base plate command over and over again, I'm going to select the joint box for that connection. That's the gray box that surrounds that element. You'll see those throughout your model. I'm going to right click and choose propagate joint. Propagate joint will find the similar columns in the model and place that connection for you. So with a simple right click, we just place 8 connections. That could be 100 connections, it could be 500 connections, all at once. This also creates a master-slave relationship for that connection. So now I can go back to my original. I can go to Advanced Joint Properties, make changes to that base plate. Here, I'll just pick one from the library. And all of the propagated base plates receive that change. So now we have a change it once, change it everywhere behavior, just like we would if we were creating this in Revit. And you can't make those changes any faster than that. All with a simple right click to create that relationship. Plenty of options for adding your components. You have advanced copy. You could place them one at a time. Propagate joint is the most intuitive of them all because you get control over your changes. All right. Moving on here, next element I'd like to create is a stair. Before I do that, I am going to reset the UCS because it is still tied to level 1 and we're active on that. You can also deactivate that level, or I can activate level 0 and that will make sure that the stair is associated with the floor. So why don't I do that? So I activate level 0, reorbit. We'll also turn off all the visibility, which essentially makes the model visible. We'll also go to the advanced tools and we'll reset the UCS back to the world UCS. Now for the stair, you may want to add some construction lines to help you determine your slope or your start and your endpoints, things like that, which is what I did ahead of time. So I'm just going to turn on my construction layer. And I've got some predefined lines that I'm going to use to place the stair. The stair command is pretty straightforward. All you really need are your endpoints. So I'll turn on my running endpoint snap here. And you'll determine the alignment. And the defaults are left, middle, and right. And that'll place a stair, something like that. Now the stair has a lot of settings in it, and it probably won't place it exactly where you want it on the first try. So we'll set all our settings. We've got control over the tread type, the sizes, how wide the stair is, what our landings need to look like, what steel shapes are being used. Plenty of settings in here. Now to save time today, I have configured one. So I'm going to go into my library and choose the stair that I saved. And let it fall into place on its own. So that takes care of the stair. The next thing I'll do is add some railing to it. The railing command is right next to the stair command. You'll find that on the Home tab. Railings need to be hosted. So make sure that you select all of the objects that need to host your railing. Then you'll press enter and then you'll choose the start point and the end point for the railing. For stairs, I usually start at the bottom for the start point. And then the end point is typically at the other end of the stringer, at the top. And here's your settings for your railing. I do recommend that once you do all of your settings the way that you want, make sure you go up to the Properties tab and go into the library and save your values and give it a name. That way you can repeat that stair later. For now, we'll just accept the defaults. It looks pretty good. Now I could use the advanced mirror command here to place one on the other side. Here I'd like to just run the railing command again, just so you can see that workflow one more time. Here I'm selecting the two stringers. and then the start point and the end point. But notice on this railing, the kick rail is on the opposite side. So here I will go into the properties. We'll go to the kick rail properties, and we'll change the alignment from right to left. That's one thing you'll find yourself doing quite a bit, is just making something from the outside to the inside on a case-by-case basis. So there's your railing. Now we had some existing railing here, so obviously there's no connection between the two as we're coming up the stair. We'll use the miter tool to achieve that, but before I do that, let's clean up this view just a little bit. We've got a lot of connection boxes here, and sometimes that can make it hard to see, or I might accidentally pick on one of those, so let's remove these from the view. Now, good rule of thumb here with the connection boxes, you don't want to select a connection box and delete it. That could have an adverse effect on that joint. It could blow it apart, so you don't want to delete a connection box. We just want to remove it from the view. To do that, I'll select one of these, and then I'll do right-click and select similar, and then go into the Advanced Tool palette and down to the Selection Tools and Selected Objects off. That just takes them away from the view, and now I've got a clear look at that area. And so now we can do some mitering on those railings. You'll find miter under the features in the Advanced Tool set. And miter works on just about anything. Always pick the objects involved. And if you want to work on the settings there, that's fine. Usually I wind up just closing it because all I want to do is a good old miter. And if you find yourself having trouble selecting, you may just need to zoom in a little bit. Okay, looks like we're getting some sort of an error here. So in the interest of time, I'm liable to just let that go. Yeah. I'll do the top one and make sure what's going on here. And that looks good. We'll just do one more here. There. So that's the miter tool. The miter is controlled by this green box that you see here. And so if you need to delete a miter, that's how you would do it, is by deleting that green box right there. I'm not sure I need to do the miters on the other railing. So I think for now, just let that go, just to cut down on the repetitiveness here. All right, and let's finish up with some railing on the platform here. Again, we'll select our host objects, which is going to be these three beams here. Our start point, we'll choose the end of this beam here, and I'll use a snap override for that. Again, if your kick rail is on the opposite side, you'll go into the handrail tab and then kick rail properties, and you can change the alignment. This one looks pretty good, so we'll just accept it the way it is. So that'll finish off our railing. Next, I'd like to add the grading in this area. Now, you didn't see it when I turned on my construction layer, but there is a polyline that is sitting on top of the beams there. It looks like that. And we're going to use that to create the grading. And this time I'm going to pre-select the polyline and then run the plate at polyline or the grading at polyline command. And that will simply turn that polyline into grading. Now, I did this on purpose. Notice that the grading is down on level 0. My expectation was level 1, And that is because level 0 is the active level right now. So that grading is now constrained to level 0. Let's delete that one. We'll activate level 1 because we want it to be constrained up there. We'll go ahead and turn the rest of the model back on. And if you're having trouble seeing that polyline like I am, we'll hide an object. And you can see right there is that polyline. And we'll repeat the command, which is grading at polyline. There's a grading at polyline and a plate at polyline. So as long as we have a little planning up front, we can make sure that these elements land where they're supposed to when we need them to. For the grading itself, there's plenty of manufacturer specs loaded into the database. These are all standard. If you are used to working with grading, a lot of these ought to be familiar to you. For my example, I'll just use the grading US Imperial and pick one from the list for the size. All right, very good. And that'll take care of the grading. There's one more object I'd like to create, and that's going to be a cage ladder. Cage ladders rely heavily on the current UCS. So the first thing you want to do before you place any ladders is move your UCS into position. Now I could use AutoCAD's original UCS move command, but I have found after working with Advanced Steel that these tools are much easier because there's no typing involved on the keyboard. I can just click this button here and I'm running the UCS move command. I'm going to place the UCS at the node at the end of this beam because that's also at the center of this column. So I am going to use a snap override and choose the node snap so I can snap to the analytical endpoint of that beam. Then I'm going to move it one more time. So I'm going to repeat the UCS move command and drag it down the y-axis 5 feet. So that's where my ladder is going to start. So remember, that's the first thing you want to do is move your UCS into position. The next thing you want to do is orient the y-axis to a certain direction. With cage ladders, they like the y-axis to be walking in the same direction as you would as you approach that ladder. So what you'll find yourself doing is rotating around Z until Y is pointing in that approach direction for that ladder. In this case, it will be in this direction here. So all you do is just keep clicking your rotate button, depending on the axis that you want to rotate around until you see what you want on the gizmo. And then we'll run the cage ladder command. Now, since we moved our UCS, I don't need to snap. I can just enter 0, 0 for the start point of that ladder. Then we're going to drag straight up, and we'll enter a distance. Here I'm entering 12 feet, which is the distance up to the upper level. But Advanced Steel creates too much ladder. That is just what it does. It really doesn't matter what distance you put in. You will get a ladder that's taller than what you need. That's fine because I can come into the ladder properties here. I can change the height. I can set the extension beyond the level, how it's oriented, the width, and all the other items, just like connections like a clip angle. Our run configurations are in here. There's too many settings to go over in a 1-hour webcast. So what I'm going to do here, like I did for the stair, is go into the library and choose my cage ladder and let the software do the heavy lifting. And there's your cage ladder. All right. Next thing I'd like to show you is some weld features. I'm going to pretend that I'm going to weld these wall connections to this beam here off the cage ladder, but notice when I zoom in here, there's an interference right there. You can see it plain as day. It looks like it is going into the web of that beam there. So I need to back it off just a little bit. I'm not real interested here about shortening that angle. What I'm going to do is I'm just going to move the whole cage ladder out a little bit. So ahead of time, I went ahead and found out what the web thickness is, and I'm going to use half that distance to make my move. The web thickness, if you double click on that beam and go to the Properties tab, then there's your web thickness right there. So the Properties tab exists when you double click on any advanced steel object. In this case, that's what we're after, so we'll use half that distance for our move. Now, like we did with advanced copy, we want to use advanced move here because there are many, many objects in that cage ladder. They're all individual, so I can't just pick on one and select the whole thing. But I can select the joint box. I zoomed in here so we can watch this move because it is going to be very subtle. Just make sure when you need to move something like a cage ladder or a stair or a railing as a whole, make sure you select the joint box. Then we'll go back into the advanced tool palette. We'll go to tools. We're going to advanced copy, but we're going to choose the move option. We'll make sure include additional connections is checked. Our UCS orientation, so we're going to move in the Y direction. And then our distance is half the web thickness. We'll preview. Looks like it nudged it out just fine. If it looks good, we'll click OK. So now we've got a face-to-face interface between those two objects. And now I can put my weld in. You'll find welds on the Objects tab in the ribbon, and they're all the way on the end under Connection Objects. So if we need to place individual bolts or welds, this is where you'll find those tools. Right now, we're just going to do a weld. And with a weld, you just select the objects involved in that weld and use a snap to locate it. The welds are intelligent. They'll become part of your drawings when we start producing them, and you set your size and all the other properties associated with the weld. The weld is represented on screen by a pink plus sign. So I'll switch to a wireframe view here just for a moment so you can see those. There's one, and these are all over the model. If they're part of a connection, they'll be there. You just may not see them all the time. So there's the weld we just placed right there. And that's how you add a weld. Got one last operation to do on the model, and then we'll be finished. And that is to add notches to the grading. Right now we've got interference between the grading and the columns running up to the top floor. Now I'm going to start down here at the column in the corner. The railings are kind of in the way, so I'm just going to turn that layer off for the time being. I'm also going to turn the weld layer off just to get those out of view. And then we're going to add a notch. Now when we're adding notches, I say notch. Advanced Steel likes to refer to those as contours. So if you're thinking about notching something or cutting something, the commands you're going to go after are the contour commands, which are on the Advanced Tools and the last tab, Features. And then they'll be in the orange section down here. These are all our contours. or the tools we'll use to cut things like grating and so forth, or plate. Another setting I want to look at is on the Objects tab, and it's on the Switch panel. There's an option here for the behavior of those contours. We can do exact cross-section, which would cut exactly around the column, or we could do a casing cross-section, which will box that out and make a more square contour, and that's the one we're going to use. So we want to make sure that we are using casing cross-section before we start. Then, to create that notch, we're going to use Element Contour, and then we pick the plate or the grating, and then you pick the cutting element, which would be the column. There is your notch, and then we'll add some clearance to that. I'll add a 1-inch gap, so we have some space between the column and the grating. Since that is a feature in the model now, we can select it and we can copy it and use it to cut the other locations instead of having to pick the plate or the grating, pick the next column, and repeat that. Why don't we just pick that feature right there and then use Advanced Copy? So we'll go back to Tools, Advanced Copy, and this time we'll use the Array option and place them all at once. All right, now we do want to make sure we check the UCS when we do this. We haven't moved it since we did our ladder, so we'll just follow the current UCS. So based on those settings, in the Y direction, looks like we need 2 copies. In the X direction, we'll need 3. In the X direction also, we're going to go in a negative direction because of the UCS. Minus 15 feet, that's the distance in that direction along the grid. And in the Y direction, it'll be 20 feet. We'll preview that, and then we'll choose the corresponding entity, which will be the grating, because we want those copies to cut that feature or that object. Now we're in preview mode, and we can go and take a look at our other columns and see how it looks. That one looks good. Looks like those notches have been created just fine. Yes. If not, then we go back and modify. Looks good here, so we'll choose OK. And now we've made our cuts around our columns. We'll turn our other layers back on. And there is our model. All right, we've done enough modeling. So now let's take a look at creating drawings. I am going to just tidy up the model space here. I'm going to deactivate all the levels, make sure everything is visible, and reset the UCS to world. The first drawing I'd like to show you is one of the part drawings. I'm going to use a clip angle as an example here. So I'm just going to zoom in on one of the clip angles and select just the angle, like so. I'm also going to open up the other advanced tool palettes. We've got one for drawing processes, like so. I'm just going to dock it with the other ones. And then drawing styles. So we've got 2 different ways to make drawings in Advanced Steel. The drawing processes will produce your part and assembly drawings. The drawing styles will produce your plans, your elevations, etc. So for this clip angle here, I'm going to use a drawing process. And I'll just use the selected one here. SP means single part. And then I'm going to choose which size drawing that I want to use. This is just a single part, so A or B size will probably be good enough. So we're just going to run it and let Advanced Steel create the drawing. Now, once you start creating drawings in Advance Steel, you'll use the Document Manager to work with those drawings. When you first create them, they will wind up under the Details branch of the Document Manager. And there's the drawing we just created. So let's go ahead and open that. And there's the drawing. As you can see, the title block is there. It's populated. There is a part list and enough views to describe the part along with the dimensions. If this had welds, you'd see the weld symbols, other labels, part numbers, things like that. So really, the goal here is to produce the drawing and not have to do any post annotation on it. If you do need to do post annotation after generating drawings in Advance Steel, you can use the Labels and Dimensions tab, and all of the tools you need are there. Labeling in Advance Steel is intelligent, and so is dimensioning. This could be a webcast on its own, so unfortunately we don't have time to go any deeper than that on that topic today. So there's the first drawing, which is a part drawing. So I'm just going to close that. Next, I'll show you an assembly drawing. To do an assembly drawing, you'll select the objects, the main objects for that assembly. So I'll select these two columns in the beam. On the Assemblies tab of the drawing processes, again, you'll choose the selected assembly and then whichever drawing size you want it to be. I'll just go with ANSI D on this one. And once it's created, we'll go back to the Document Manager, and now we'll see the assembly drawing. And here's an example of that. And again, we've got the appropriate border. It's populated. We've got a bill of materials and every view that is needed to describe the assembly along with all the dimensions. One of the things that you may notice as you start exploring this is you may have overlapping annotations like right here. That's no problem. When you see some of that housekeeping, then those can be moved out of the way and things like that. So there might still be some tidying up to do, but it won't be from scratch. All right, this one here, we're just going to close that. So those are your drawing processes. Next, I'd like to show you a drawing and views as an example. The drawing styles rely on the current UCS. So make sure that you set the UCS to the location that you want before you create a drawing using a drawing style. So I've already done that, but make sure that is your step one here is check your UCS. Right now, I've just got it set to world, and then I'm going to create a plan view full. Now, when it comes to creating the plan views, I also like to switch to a top view in model space. That makes it easier to select the area that you're interested in. So we'll do plan view full. And then we can create with the default settings. We'll give it a drawing name. The border's already been predefined, and the scale. I don't like drawings that just have a number. So I'm going to choose modify settings on this one, and we'll deviate from the default on a few things. First thing is the drawing number. I'm just going to give it the drawing name, like so. I'll stick with the scale. If I want to, I could turn off things like the grid, any weld symbols that might show up, and they won't be part of the drawing. If I want to change which template or prototype I'm using, then I can do that from here as well. And then we will choose the area. Right now, just surround the entire model. And now we have a drawing for the ground floor. certain things are being labeled here. The columns and their size and shape are listed there. And the dimensions would be there as well, depending on which drawing style you choose. The one I chose did not include the dimensions in this case. Now, we've created a couple of drawings. What happens when we modify the model after we create the drawings? Let's look at that. So I'm going to make a change to the model. What I'll do is select all the footings. I'll use select similar. And then we'll go into advanced properties and we'll change the size of the footing. Now, as soon as we do that, we can go back into the document manager and notice that now there is a drawing underneath the new branch called update required. So once you have created drawings, you go back and you make changes to your model, the document manager will track those drawings and let you know when an update is required on those. It won't automatically update those drawings without your say-so. So it is up to us because we're going to do a revision and we need to be able to control that. So let's select that drawing and then go to update revision. We'll add a revision. Give it a description. And once we click OK, then Advanced Steel will update that drawing. It will tell you it's revision A now. And if we open it up, we can see that it is revision A. Now, I also notice, and of course this is happening while I'm live here, we're supposed to see the revision clouds and triangles in our views. I don't see that here, and I would like you to be able to see that. So I'm going to assume something is wrong there, and I'm just going to make a different change and see if I can make that happen. And since we did make a drawing of this clip angle in here, or just the angle, what I'm going to do is make a change there and see if that's going to play. Of course, it worked when no one was online here, and that's okay. We'll just move on. So I'm going to go into advanced joint properties on that clip angle and just make a change. I'll just change the number of bolts to 2. And then we'll go back into the document manager. And now we can see that our part drawing needs an update, so we'll do an update revision on that. So now that drawing's back in the up-to-date branch. Open that up, and there you go. So I just wanted to make sure that you could witness that when you do a revision of a model, the drawing notification will be tracked, and when you update that drawing and add a revision to it, the clouds will be automatically added to your drawing for you. And so that should be a huge time saver for those of you that work in that space and you're revising drawings on a regular basis. Of course, the settings you're seeing here, this is all out of the box. It is all controllable by you. Those are things that we cover when we conduct our training class for Advanced Steel. So fear not, we can make it look like what you're used to when the time comes. So there's a little touch on the drawing creation as well as what happens when you make revisions. Last thing I want to share with you today is how to move steel between the Autodesk products, namely Plant 3D, Revit, and Advanced Steel. So First, I'd like to bring some in from Plant 3D. To do that, I'm just going to start a new drawing. Use the Advanced Steel template. And then I'm going to go to the Export and Import tab and use Import. Now, I went ahead and did this. This was modeled in Plant 3D. Beforehand, I exported the SMLX file from Plant 3D so I can bring it into Advanced Steel. Here's my Plant 3D project right here. So I'm going to go down in there, and I stored this in the Related Files folder right here. So the SMLX format is what we'll use to bring steel in and out of all the applications. And here's what we get from Plant 3D. I'm going to change that to a conceptual view there. So what was exported? I exported everything that's in Plant 3D. Notice here that it looks pretty good. These are intelligent objects now, so I can double click on a column and I get the same information that I would get if I was in Plant 3D. But it is now in Advanced Steel format. However, there are some gotchas here. For example, the grid. I have 3 grids now. There's one on each level because that's what was in Plant 3D. You do not need a grid on each and every level in Advanced Steel. It won't hurt to have them there, but it could clutter your model. So you might wind up doing some housekeeping on things like that. The other thing to point out is things like mitered corners or steel that has been trimmed or cut back in Plant 3D. All of those features will be lost when you bring it into Advanced Steel. Because in Plant 3D, those are conceptual. In Advanced Steel, they're intelligent. And so that's where that gap is. So you can see that here. There's some mitered corners here, or they should be, but they're not. The railings and the stairs are another gotcha. This is not a stair object right now, so there's no joint box. It's simply stringers, treads, and pipe for the railings. It's all individual objects busted apart. So if your intent is to work that stair and get it ready for fabrication drawings in Advanced Steel, you're probably going to be deleting these and then recreating it with the stair tool in Advanced Steel. So this might take some planning to get it to where you're not having to do any excess cleanup when you're bringing steel over from Plant 3D. The other thing that you'll notice that's not here are the concrete foundation objects. There are footings in the Plant 3D model, but they did not make it across to Advanced Steel here. So I'm just going to delete that and then import it again and import my second one, which is a simplified version of the same thing. So when I bring this one in, notice I still get all my grids because you want at least one of them. So you can just delete those and just the steel. The objects that you know that you're going to create with Advanced Steel, it's a good idea to not make them part of your SMLX file when you export. And you can do that just by freezing those layers in Plant before you make your export. And that'll cut down on, picking and choosing all those busted apart objects and to clean them out. So just keep that in mind. Now, when we're taking elements into Revit from Advanced Steel, what we would do there, when your model is ready for that, we would do an export, create the SMLX file, and then import it into Revit. Now, with this many elements, that would take a few moments, and I don't want you to have to watch that on screen, so I have done that ahead of time. And here is the model that we just finished in Advanced Steel. It's all here. We can see the footings. We can see the railings, the stairs. We can even see the connections, and that's the big difference between Plant 3D and Advanced Steel and Revit. When you are communicating between Revit and Advanced Steel, you will get the connections. However, the stairs and the railings are still busted apart objects. So we can't double click on something in the stair and have the stair interface come up. All we would get is the interface for that particular element. Of course, that's a family in Revit, but we would not get the stair interface. So again, this is channel, that's plate, and that's pipe, etc. Everything is in place, however, so if Advanced Steel is the driving force for something like a stair, that's fine, because in Revit, you may just need it to be there to occupy that space and show up on a drawing, but it's not going to go any further than that, so you might be okay. The other thing to watch out for when you're bringing SMLX files into Revit is on things like grading. It looks good now, but I did have to make a tweak to the material so that it looks like grading when I use a realistic visual style, or if I'm going to render, then you might have to make a tweak to that material. Usually when they get imported, they come in as solid, and it looks like plate, even though all the properties say it's grading. So just a minor tweak there. It takes just a few moments to take care of that. So there is some workflow here, but there are some gotchas when you're going from one to the other, and it seems to be with those assembled objects like stairs, railings, and ladders. So if you're going to create those in Revit, leave them out of your SMLX, and same with Advanced Steel. If you're going to create them in Advanced Steel, leave them out of your export from Plant 3D. Okay, that's all I have to share with you today. I do have a couple of tips I'd like to share with you. First, I'd like to highlight where to go in each product for importing and exporting the steel. In Revit, you'll find it on the Add-ins tab. There'll be an extension for Advanced Steel. Just make sure that the Advanced Steel extension for Revit has been installed. In Plant 3D, you'll find it on the Structure tab, and it should be near the middle of the ribbon somewhere. It's just one big button. There's no extension to install. When you install Plant 3D, that command is part of the install. And in Advanced Steel, you'll find it on the Import and Export tab, all the way to the left. Although those buttons, or those commands, they do refer to Revit, it doesn't matter where the SMLX file comes from or where it's headed. However, the synchronize command, it only works with the steel between Advanced Steel and Revit. That's one that won't work with Plant 3D. These commands, it says Revit on the icons because that's the typical workflow with Advanced Steel. There could be some back and forth there between those two products. Usually with Plant 3D, it's a one-way trip. And that's because we typically model our conceptual steel in Plant. We don't do the connections. That's usually finished up in Advanced Steel. So if a project in Plant 3D needs those details back, or if the user in Plant 3D wants to see connections, for example, in their Plant 3D space, then what they'll do is do an XREF of the Advanced Steel model back into Plant 3D, because there is no import of the SMLX for Plant 3D. So we'll use good old XREFs, which leads to the next tip. If you're using multiple AutoCAD-based products, in this case we are, or if you're using Navisworks, you'll need to install the object enablers for Advanced Steel and Plant 3D. Those will enable the model objects when you're doing your XREFs. For example, when XREFing a model from Advanced Steel back into Plant 3D, you'll be able to see the connections and all the features that Plant 3D can't produce. So when you touch on those, you highlight them and you look at the properties, you'll get that information. If you don't have the object enablers installed, you'll get the proxy information dialog, and some objects won't show correctly. Also, just like with any other product from Autodesk, there's good overview information on Autodesk.com. Here are our resources that you can take advantage of for self-help. On our YouTube page, you'll find the recordings for all our previous webcasts. This one will be available shortly. Plus, we have plenty of articles on our blog at hagerman.com and even more content on our customer hub. Lastly, we have a new class offering for Advanced Steel. For information on that, you can give us a call and we'll be happy to go over the details with you. I'd like to thank everyone for attending today. Now we will answer any questions left over from the chat window. Dan, do we have any questions?
Yeah, Brett, if you want to take a look, it looks like there's 2 or 3 questions that came in. If anybody's got any other ones, feel free to type those in now.
Yes, here we go. Okay, so that first question there, client wanted a sloped cage ladder. Can that be done in the program? Yes, it can. Again, that would rely on the UCS. Of course, you only saw me use it in conventional matter, so it's always flat, but you can tilt the UCS so it's on an angle. As long as your Y direction is pointing accordingly, then you can create those slope ladders. Well, we won't have time to do that here, otherwise this could be a really long webcast. So if that's something you want to get into, if this is support related, then maybe we could open a support case for you and work it that way. All right, so next question. How can I have a beam system line always at the top while at the same time have columns always at the center? I would like channels, angles, correct default locations, all different. I'm assuming that you are referring to the position tab when we're looking at the properties of a beam or a column. And there really isn't a beam system command. So when we're creating beams, we are creating them one at a time. It's not like in Revit where we run a beam system command and it puts all the beams in as a group. So I'm not sure what you mean there. But it sounds like you're referring to properties where you're setting the justification in center, top middle, top left, top right, etc. And that is typically done for each component, right? So, because as you work your way around that system, your C channels on one side might be justified to the top left corner, on the other side, there might be top right corner. So it would behoove you to check those as you're creating them. I hope that answers your question. If not, let me know. All right, next question, like columns to move when the grid line moves and the beams to adjust with that move. Can this be done? That's a good question. With the columns to move, if you move the grid, I'm going to be honest with you and say I don't know because I've never tried it with adjusting the grid and having the columns move with it. So that's one I'm going to test as soon as we're done here today. Now, for the beams, once the connections are placed, so let's say you do your columns, you place your beams, and you put in some clip angles, for example, and those connect the two together, then yes, when the column moves, the beam will stay connected to it and adjust accordingly. All right, so next question. When dealing with slope form, well, a lot of slope questions today. I like it. How does Advanced Steel handle floor sloping from level 1 and 2 in the document generator? So by how does it handle, do you mean how is it shown? I would think when you're spanning from one level to the next, some objects might get cut off because those rely on the UCS. Now, there is another feature for drawings that I didn't show you during the demo portion, and that is camera views. So if you have objects that cross from one level to the next, and you want to make sure it's shown correctly on your drawings, you can create a camera view. And that camera has a box associated with it for clipping purposes, and you can make that box whatever size you need and use a camera view instead of one of the other drawing styles that I use, like the typical plan view, which only shows you, the plan and a little bit above and a little bit below. So take a look at camera views for that sort of thing. All right, last call for questions before we wrap things up here. And gang, if anything I just answered, if you're not satisfied with that, feel free to email us and that will get forwarded to me, and I'll be happy to work on that and get back to you as soon as I can. So it looks like that's it for the questions. Thanks again for attending. Ashley, back to you.
Okay, thanks, Brett. This will conclude our broadcast. If you think of additional questions, you can simply reply to that confirmation or reminder email that you received from GoToWebinar, and we can get those to Brett or your sales rep to get those answered. Once again, if you could just fill out the survey, we would appreciate it. It would just pop up as we close down today. Thanks for attending, and have a great day, everybody.